Hi, so what we're going to look at now is reacting Grignards and organolithiums, so essentially carbon nucleophiles with esters. Now, when we did this with ketones, we added them to the base of the carbonyl. And with esters, we're going to have that same idea. We're going to add here at the base. The difference is we're going to add whatever our carbon nucleophile is twice. Right, so we have the 2 telling us that there's 2 equivalents of this. And what's going to happen is we're going to lose the oxygen portion of our ester, right? So the alcohol portion, and we're going to add the CH3 group to it. So let's draw our carbon framework. We get an alcohol, just like we did for when it was a ketone or aldehyde. Difference now, we're going to add 2 of whatever our carbon nucleophile is. So in this case, it was CH3. We added 2 of them. All right, and then we usually work this up with acid and water at the end to put that hydrogen on the OH. Same thing on the bottom. In this case, the lithium tells you that we're going to add this ethyl portion. We're going to add it twice. And same as before, we're going to lose the alcohol portion of the ester. So let's redraw the carbon framework. We get an alcohol. And then we're going to get the ethyl groups coming off of that base of the carbonyl. So remember, we still have the same idea that we're going to add to this group. And we're going to keep that same carbon there. And then whatever our carbons were in our nucleophile, they show up in our product. So for example, it's 1, 2, 1, 2. And so those are carbons we've added to the base of the carbonyl. And the difference here that we've done before, and let me just show you quickly, is that our first intermediate is that same tetrahedral intermediate that we've been talking about. We have our oxygen, our carbon group coming off of it, and then whatever our nucleophile was. Right? So in this case, it was that carbon. Right? This portion here came from here. Now, it's really, really hard to break carbon-carbon bonds. So when this negative charge, or pair of electrons, pushes down and reforms a carbonyl, we're going to kick off that oxygen group. And so what this leads to is the formation of a ketone with that first nucleophilic portion added. And then what happens is our nucleophile can add a second time, resulting in our alcohol and the addition of 2 carbon groups. Alright, so the take-home message from this is when you have an ester and you react with a carbon nucleophile such as an organolithium, a Grignard, you're going to add it twice and then you're going to lose this portion. Alright, so we're going to add our carbon group twice and lose the oxygen carbon portion.